The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more.
What are we trying to do? I mentioned an industry problem. Well, how did the industry problem become created? Well, we're trying to replace over 100 years of ICE infrastructure with electric, and at the same time domesticate the end-to-end supply chain, which includes mining, right? Which mining has not been that popular in the U.S., for example. It's more popular up in Canada, where they've been mining for decades, if not over a century. But there still are regulatory hurdles, societal friction that can be created that has to be addressed.
Are you speeding the energy transition? Here at the Clean Power Hour, our hosts Tim Montague and John Weaver bring you the best in solar, batteries, and clean technologies every week. Want to go deeper into decarbonization? We do too. We're here to help you understand and command the commercial, residential, and utility solar, wind, and storage industries. So let's get to it. Together we can speed the energy transition.
Today on the Clean Power Hour, my guest is John DeMaio. He is the CEO of Graphex Technologies. Welcome to the show, John.
Hey, Tim. It's great to be with you again.
Please check out all of our content at cleanpowerhour.com. Give us a rating and a review on Apple and Spotify, and please subscribe to our YouTube channel. So, John, it's great to have this burgeoning ecosystem of storage technologies and storage companies on the scene. Your company is called Graphex, and you make components for lithium-ion batteries, among other things. So give our listeners some background on yourself. How did you come to energy storage, and what are you up to at Graphex?
You bet. Okay, well, I'll try to be brief on my background. I'll sum it up to say that I've been in the energy transition space long before it was called that. I began in solar concentrators out in the Mojave Desert years and years ago. Worked on a lot of combined cycle and heat recovery, energy efficiency type projects at various companies. Spent a fair number of years at Siemens in the Smart Infrastructure Group, where we tackled what I call reduce, produce, procure, protect, meaning reduce the energy consumption, produce on site, procure wisely, and then of course protect those efficiencies over time, all in an effort to really reduce the human footprint on the planet from an energy perspective. So been very proud of the work that I've done over the years, and kind of gravitated towards this space. I'm running a company, which we'll talk about, I'm sure. We produce the graphite that goes into the batteries for energy storage and electric vehicles, et cetera. But all part of this, again, this transition away from fossil fuels and to a more sustainable future. So really pleased with the momentum in the industry. It's the first time in my career where I've seen such a strong alignment all across the board, meaning, from legislation to funding to industry kind of momentum. I think we can all agree that this electrification movement is really going only in one direction, and that is towards electrification and away from internal combustion in the case of transportation. So never have I seen the stars align so firmly to really ensure that this actually happens. I've seen some fits and starts over the last several decades, all kind of cumulatively going in the right direction. But like I said, this has been a real across the board kind of push, and it's really encouraging to see.
Yeah, we're at the right place at the right time, and that only happens, maybe once in your lifetime if you're lucky. So it is great to be part of the energy transition and electrification of transportation. Americans don't quite see it yet, although they certainly saw it in the Super Bowl ads the other day. And, companies like GM and Ford are electrifying their fleets. And while EVs are just a couple of percentage points of new car sales in the U.S., you look to the future, look to Northern Europe, and you see very large percentages of new cars are pure EVs in Germany, in Norway, and the writing is on the wall that the internal combustion engine is not going to be competitive. It's not a matter of liking batteries or not liking batteries. It's just not going to be cost effective to move things around. And so the ICE engine is going to disappear. And it's going to be a tipping point phenomenon, ice, water, and then poof. So the good news is we have the technology. We have some of the major companies now, like Tesla, that have really seeded the market and got the industry flowing and proven that consumers really do want EVs. And now it's going mainstream. And within, it's the latest predictions I think I see are like in the 2030 range when, internal combustion engines will no longer dominate the U.S. car sale market. So we got a few years to go, but then it's going to be precipitous and ICE engines will go extinct for the vast majority of applications. There'll be, some niche applications here and there, but, the oil companies really shouldn't worry too much because we're going to make lots of plastic and stuff from oil still. And it is annoying that the oil companies are kind of fighting the electrification of transportation and the energy transition, but it's a lost battle. So let's talk about Graphex though. What exactly are you up to? How did the company come to fruition? And what is the market in the next 1 to 5 years?
Yeah, you bet. So we probably should start with what Graphex does, right? So we're referred to as a midstream processor or midstream refiner of graphite into anode material. What that translates to is that we do not do mining, right? So our input product is an output from the mine. So we receive what's called flake graphite or graphite concentrate. This is the natural product, right? This is the ore that comes out of the ground, is mined, is concentrated to a purity of about 95% carbon. Right. So that's what we acquire as input. We then take that and refine it to a 99.95% purity, put a special coating on it, and that becomes the anode material for a battery, storage battery or EV battery. And within the battery, you have 4 basic components: a cathode, an anode, which are the 2 electrodes, positive and minus. And then you have electrolyte and separator, which are kind of more inert, kind of facilitators, if you will. Cathode and anode are where the action happens. Electrons go from one to the other during discharge and backwards during charge. So although a lot of attention over the last decade or so has been placed on the cathode side of the battery, the positive anode or the positive electrode, that's your lithium, nickel, cobalt, manganese. The anode side is almost always, it is always graphite, up to 99% graphite, maybe a little bit of silicon. Sometimes there's a combination of synthetic and natural graphite, but the anode is always graphite. So basically half of the battery, the money-making parts of the battery, if you will, where the action happens, is graphite. So in a typical individual cell, 48% is graphite. You expand that out to the entire battery where you may have 800 to 2,000 of these individual cells making up a EV battery pack. That becomes about 25%, 28% is graphite. So people don't realize there's 15 times more graphite in a battery than there is lithium because there's been so much attention placed on the lithium side. Graphite's kind of the unsung, kind of the anonymous, if you will. Mm-hmm. I call it the working man inside the battery. It does an important role. It performs an important function in that it stores the electrons and then releases them, in the charge and discharge cycle. So it's a hardworking member of the battery ecosystem. It is natural, it's stable, it's inert, To a large degree, it's recyclable, meaning that it can be used as, lubricants and coatings after it's served its purpose in a battery. So it's a very versatile material, and it just sits there and does its job. And there's really no substitute for it in the foreseeable future. So we refine that graphite. We've been doing it for over a decade, primarily solely in Asia and China, because that's where the electric vehicle market is, and that's quite frankly where 90% of the world's graphite has come from historically. Now, with that said, as electric vehicle proliferation has taken root, as you mentioned, in North America and now moving into Europe as well, there is a need, and aside from the sheer numbers of cars, vehicles projected, and each vehicle needs a battery, and each battery, as we just talked about, needs graphite. There's also a push to domesticate supply chains, particularly in North America, and to move away, from countries of concern, namely China and maybe some others. So Graphex is basically taking what we've learned and perfected in an established ecosystem, namely the China EV market, and we're bringing that technology and that know-how to the States, to North America, and on into Europe. So it's an important kind of stepping stone, if you will, a foundational play for this electrification movement that we are proud to be a part of, and very happy to do it, into areas that are benefiting from the technology being brought in, from jobs being created, and really from bringing the auto manufacturing, quote unquote, back home. So that's the role that we play and the product that we provide.
Yeah, I'm glad you mentioned onshoring and reshoring. China manufactures, I think, 70% of the battery cells, the lithium-ion battery cells in the world. And they also make 70% of the solar panels that are consumed in the world. And I have nothing against China. I think they're an amazing country and an industrial powerhouse, bar none. But we need to be careful, right? Because it is there is the potential for conflict between the U.S. and China, and so we just need to do our best to regrow our manufacturing sector. It used to be a huge part of the economy, and now it's a small-ish part of the economy. But the IRA legislation is incentivizing the reshoring and onshoring of battery manufacturing and EV manufacturing and solar panel manufacturing, and it's working. There have been well over a dozen announcements of major gigafactories and EV factories and solar panel factories since that happened last, I guess, August or September. So this kind of industrial policy really does work, and it's going to create lots and lots of jobs here in America. These are high-wage manufacturing jobs, and it's going to reduce the supply chain headaches that we've had in the last 24 months of stuff being shipped all over the globe. That shipping is going to continue, but if it's made closer to home, it's going to be less complicated to get our grubbies on it and make batteries. So that's just a good thing, and it's a common sense thing, really. It's so interesting, that graphite in pencils, like a graphite pencil is something that all American children know what it is. We forget as we grow into adulthood, we use pencils less and less, depending on our trade. But you take that pencil and you draw a line, and then you take a piece of Scotch tape on that line, right? And you can pick up a graphene, a single layer of this pure carbon that is super. It's a super material. Carbon is so fascinating, right? It makes diamonds, it makes carbon black, and then a bunch of stuff in between. And
human beings, right? We're carbon-based life forms, right?
That's right. We are carbon-based life forms. And so it has some very important properties. That I did not know that stat, though. That's great. 25% of the battery.
By weight, yeah.
By weight. Sure. And so it is analogous to the silicon in the solar panels, right?
Correct.
There's a lot of other stuff in solar panels, but silicon is kind of the backbone. But let's talk about electrification and who your customers are exactly. How is the company coming to North America. Tell us a little bit about that and who your customers are going to be.
So our customers are the cell manufacturers, right? So that includes all of the marquee brands, right? Those are our target customers, I should say. So we haven't, we don't have any contracts in place as of now, and that's primarily because it's a kind of a long process to go through the qualification of the material to make sure that it's acceptable and will work in their battery configuration, et cetera. So there's a kind of a long testing process that has to go on. And we're in various stages of that process with many of the automakers and their affiliated battery partners, right? So that's again, our customer base. What we're trying to do, of course, as a commercial, publicly traded company, we're obviously interested in commercial success. But what we're really trying to do to achieve that is to solve an industry problem, right? To bring an industry solution to a need. And that need is the demand for these critical minerals, in our case, particularly graphite, that far outstrips the current supply. So in an ecosystem where, the gigafactories, as you mentioned, there's announcements upon announcements, et cetera, if you total up the demand reflected by those announced gigafactories, in the next few years, we're going to be in deficit or looking for somewhere in the neighborhood of 300 to 500,000 tons of graphite. And the current capacity to commercially produce that at scale in the States is zero, right? So there's a big disconnect between what's going to be needed and what's currently in place to produce that. So Graphex is a part of that solution, right? We represent, again, that midstream. What we're doing to help solve that overall problem, which is end-to-end supply, right? Meaning from the mine to the battery anode, is that we are actively partnering with and seeking collaborations with more than several, but quite a few of the mining operations throughout the world, right? Aside from China, where, again, most of the graphite currently comes from. We understand that there's, sovereign risk to some degree. There's logistical challenges that can happen, as we saw with COVID, right? So in an attempt to diversify our own upstream supply, which in turn diversifies it for the industry, we're in discussions, and you may have seen some announcements recently, for example, with Northern Graphite up in Canada, where we're seeking to form potential joint venture to, again, secure supply from the mine to the battery. We're seeking similar kind of arrangements, if you will, collaborations with mines in Brazil, in Australia, in Mozambique, Tanzania. So again, to diversify that upstream supply chain to offer resiliency and flexibility, as well as being conformance with the IRA. So that's where I say, it's in Graphex's interest to do that, but it's also, again, attempting to solve an industry problem, which is huge demand versus currently not great visibility to how that demand is going to be met with supply. So we're actively engaged in multiple conversations with multiple miners, also bringing in our customer base, right? Because we believe that there is a three-way conversation to be had here. The paradigm has shifted. It's not like the automakers can just specify what they need and there's ample supply. It's just a question of, which vendor supplies it. Now we're seeing more active engagement from the automakers and battery makers looking into the supply chain for, visibility to ample supply of quality and quantity that they need to fulfill their projections. So that's where Graphex, I refer to it as ability with agility, right? So we know how to do, our end of the supply chain. We're very good at that midstream refining. What we're doing now is reaching out on both sides, upstream and downstream, to bring that collaboration together in an attempt to really address, like I said, an industry-wide problem. So we're trying to be a good supporter of of the transition to streamline some of these, maybe shift the paradigm a little bit of how critical minerals are, procured and processed. And we're happy with the, with the role that we can play in that.
So the raw materials for graphene or graphite, they're naturally occurring, but there's also something there's some engineered product as well. Can you differentiate the different sources of graphene, and then are you propping up manufacturing facilities in the U.S.?
Yes, we will be. So we have announced quite a while ago. We announced our intentions to build a facility in Warren, Michigan, and that is partially completed as far as like the site preparation. A 15 megawatt power substation has been installed on site to support the power needs, and it's a site that was abandoned. Basically, it had been a previously integral part of the ICE ecosystem way back in the day, and this site had sat vacant for a number of years. A local group started to redevelop it, and we became aware of it and have secured a lease for part of that site so that we can build a plant there. So yes, we're talking about physical plants being built. And now again, we are talking about natural graphite processing and refinement. You mentioned, I think you were referring to synthetic graphite.
Yes, that was the word I was hunting for, synthetic.
Yeah. So similar end product, but kind of a whole different means to get there. So synthetic graphite is actually produced from petroleum coke, right? Needle coke, to be specific, which is, as you had just heard me say, it's a petroleum byproduct. And that is then refined. It's called a carbonization, or a graphitization process, which is very high energy intensive, and then creates a very similar, what we call spherical graphite. The advantage to using synthetic right now is its swelling characteristic is a little bit better than natural. So swelling is a concern within a battery cell, as you can imagine, right? If you have enough swelling in one cell, you multiply that by 2,000, you could have a problem. So in relative terms, natural graphite upon charging and discharging can swell somewhere between 5 and maybe 8%, whereas synthetic is between 3 and 5%. So that difference in swelling characteristics becomes attractive to battery chemistries, right? Which is why you'll sometimes see a combination of the two, natural and synthetic, on the anode side. In some cases, some car makers and certain models use 100% synthetic. There's somewhat of there's a cost differential because it's very expensive to produce synthetic right now. There's also a philosophical component that can play into it, given that it comes from a petroleum-based product. It's very high in energy intensive to create. So when you're talking about an electrification movement that's trying to move away from fossil fuel, there is some philosophical kind of questions that come up. Synthetic graphite in its production has about a 50% more carbon impact than its natural graphite counterpart. So what we're doing as a company, and we have pretty extensive R&D efforts that we take part in, we're looking at ways to reduce the swelling of synthetic graphite in the charge-discharge cycle, so that we can bring it more in line with synthetic and hopefully do away with the need for synthetic if that's possible. Again, not to put people out of business per se, but to really focus on a natural product that is was a lot of graphite on the planet. Not a lot of it currently is being extracted. So there is ample supply of natural graphite. And as I mentioned, first of all, it's natural. It's stable, and there are all the good things that we know for natural. Synthetic's a different animal, quite frankly.
The Clean Power Hour is brought to you by CPS America. the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more. Yeah, I'm looking at a story on Visual Capitalist, which is a wonderful website for visualizing the materials that we use in the built environment. Mm-hmm. And according to their research, and this is now dated, this is a story from the end of 2021, that the graphene industry is headed to be a $3 billion industry by 2027. I would not be surprised if that's an underestimate, but you know, when you think about scaling, you know, you mentioned that today there are no native manufacturers of this product for the battery industry, and there are battery factories popping up left and right. And I just had America's Battery Factory on the show. They're building a factory in Tucson, Arizona, and you know, there's factories happening in Georgia, in Michigan, et cetera, right, et cetera. So clearly there's a large demand for graphene because it's a major component. Where are they getting the graphene today? And you know, when you build this factory in Warren, Michigan, how much of the U.S. supply chain is going to be satisfied with your product?
Right. Great questions all. So rule of thumb, kind of a rough rule of thumb, but for every gigawatt hour that a gigafactory is rated, for every gigawatt hour, it equates to about 800 to 1,000 tons of graphite required, right? So a 30 gigawatt factory, by and large, will require, 30,000 tons of graphite, roughly, right? So in answer to your question, if you look at the projections into as these gigafactories come online, we could be looking at 500,000 tons of demand by 2028. Again, assuming that they're on schedule. So where is that going to come from? We need to basically recreate the ecosystem that China's already got in place, right? Because it's already supporting, 1 million tons of graphite requirement currently, or on its way to do so. So we need to, and you mentioned the Michigan plant. That's rated at 15,000 tons. So that is going to be a great kind of first move for us. But what we're looking at simultaneously are potential locations where we can locate much larger facilities, those that can get up to 100,000 tons per year, or maybe even 200,000. And to look at having several of those located strategically within North America to support those gigafactories, that require. So there's a lot of groundwork being done around that right now, as far as site suitability, all kinds of, the typical decision making you would expect, right? Site, the suitability, power availability, how much of that power could possibly be renewable, right, to decrease the environmental impact of building these plants. And of course, the logistics, et cetera. A lot of that, though, is driven, and not just for us, right, but the decision making that goes into, expending this amount of CapEx is definitely related to the security that's felt from the customer side, as for, specifically for offtake agreements, supply agreements, et cetera. And I say it doesn't apply just to Graphex, right? So the domestication effort to bring, again, from mine to battery for a lot of these critical minerals, there are some large CapEx expenditures that have to be made. And the industry is basically, looking for some level of commitment from the customer side before, moving forward with those large expenditures. And I think that's an area where the industry, again, a lot of the proper elements are in place, things like the IRA, the bipartisan infrastructure law, the DOE grant programs, et cetera. Those are helpful. But the industry has to respond as well with more collaboration, I feel. I was quoted as saying in an article somewhere that we need more aggressive collaboration. And I believe that's true. I think car companies, midstream processors like us in graphite and others in other minerals, and mining operations have to come together and really work through, how do we match this demand with the current supply and bringing online more assets of raw materials and having some commitment to procure those on the customer side.
Yeah, I mean, according to PV Magazine, my co-host, John Weaver, wrote an article back in January of 2022 saying we need 6 terawatt hours of energy storage by 2050 to electrify green the grid and electrify the grid, so to speak, to go to net zero by 2050. Okay. 6 terawatt hours, if you're looking at that, that's 6,000 gigawatt hours, right? And so what your factory is going to produce, I just did some quick math, is 0.25% of what we're going to need in gigawatt hours of battery storage. So the opportunity, but also the challenge, of course, is that this is a big problem. And, you can only scale things so fast, especially if it's cumbersome from a permitting perspective. And that's the thing that we in the clean energy transition, we energy professionals are really keen to see change in the U.S. is the process of permitting projects is very cumbersome and slow and easy to derail. And we need to streamline that and make it much easier and faster to bring projects online, because otherwise it's not a matter of the technology. It's the matter of our ability to deploy the technology fast enough to go net zero. And going net zero is just the beginning, right? We also have to then decarbonize the atmosphere, which is 800 gigatons of carbon pollution in the atmosphere, which is a big problem. So I guess I don't want to rub salt in your wound here, John, but what keeps you up at night when you think about scaling the graphite and graphene industries here in the U.S.?
Yeah, no, that's a fair question. And I appreciate you recognizing that the regulatory environment has to become more streamlined. And that's an industry-wide sentiment, right? And it particularly applies to the mining folks, right? So again, when you think about what are we trying to do? I mentioned an industry problem. Well, how did the industry problem become created? Well, we're trying to replace over 100 years of ICE infrastructure with electric, and at the same time, domesticate the end-to-end supply chain, which includes mining, right? Which mining has not been that popular in the U.S., for example. It's more popular up in Canada, where they've been mining for decades, if not over a century. But there still are, regulatory hurdles, societal, friction that can be created that has to be addressed, right? So I sense in the industry that there's a willingness from industry side to be responsible, stewards of the environment at the same time of bringing, the needed technologies home, so to speak, so that we can have that domestication. But there is, and you and I talked about this prior. I was in solar as well, and you do see there's some amount of NIMBY, right, that comes into play, particularly in solar when you're talking about large fields of solar panels, et cetera. But that needs to change. I don't think we're going to steamroll over that. But there has to be a balance that gets struck with the benefits of electrification, and what's going to be required to make that happen. To your other point about, a drop in the bucket, basically, yes, the one plant in Michigan is really about, again, that there's a lot of factors going into that. We really want to bring that technology back to Warren. The folks of Warren watched the automotive industry kind of leave. And now that it's coming back. It's coming back to places like Georgia and the South and other places, and not back to the Detroit area. So we're happy to be playing a part, bringing jobs to a disadvantaged kind of location, and we feel like that's a really positive thing to do. But it's 15,000 tons versus 500,000. So that's where I said the real effort, or a parallel effort for Graphex, is to investigate places where we can build much larger facilities to address that. So we're talking maybe 100,000 tons, per year in multiple locations. We'll really start making a dent in that demand. And that's where, again, selfishly speaking, we feel that if you're trying to do that transition from internal combustion to electrification, to domesticate it all at once, the fastest way to do that is to get experienced players like us to come in and plug and play, right? So that we've already proven that we can do commercial scale, right? We do 10,000 tons per year now. We're expanding that to 20 over the next 12 months, and then to 40. This is over in China now. So we already know how to do, produce at commercial scale. And we're talking 10,000 tons, 220,000 pounds of microscopic particles that meet exacting specifications. Not something that everybody can do. I say it's part art and part science. So we don't have that ramp up that goes along. We did that. We already paid our dues, so to speak, before we went commercial, spent several years perfecting, again, that part art, part science thing. So we can plug and play here and get up to commercial scale real fast, because all we're doing is replicating what we know how to do, and bringing it here. So, we feel like we can help to address the demand in a timely fashion. And the last part of your question was where the car makers getting their product now. Well, they've been buying completed cells and battery packs, from Asia heretofore, right? So it's only when they build the gigafactories where they're going to make their own cells that they will need the raw materials. So we're looking at probably 2025 and beyond as to when those gigafactories will actually need, the graphite powder, to go into their anodes. So right now they've got enough, buffer in their current supply chain to get them through the next couple of years. So we have some time to catch up, but the clock is ticking, as you rightfully pointed out.
Yeah. Well, I love it that, we're seeing Chinese companies, we're seeing Korean companies, we're seeing Asian companies writ large, invest in factories in the United States now, and it's high time. One of the things that really frustrates me is that we are busy educating some of the best engineers from all over the world at our universities, which are still some of the best universities in the world from a technical perspective. And then our immigration policy is such that we send all those engineers back home, and very few of them end up remaining and becoming American citizens. And that brain drain is really not good for our future. So we need to really reconsider our immigration policy in this country big time. So what else, John, should our listeners know about Graphex Technologies and electrification of everything? I'm really pleased to have you on the show, and I wish you the best in scaling. Clearly, right, there's a ginormous opportunity here and need to onshore graphite production.
Yeah. I guess the other thing, because you touched on the the immigration, so people should recognize Graphex is not a Chinese company, right? We are considered a foreign entity in China, so most of our ownership is U.S., Canadian, UK, et cetera. I bring that up because it makes it, and we spent a fair amount of effort to maintain that wholly foreign-owned enterprise status, because it gives us that flexibility to bring technology. The technology is our own, so we can bring that over to the States without any kind of impairment or impediment, as well as the talent that's required to burn in these new plants. So it's another element of it. It's actually one of the things we're very pleased with is that we're not bringing technology back to the U.S. because this technology is not here right now. We're actually bringing technology from Asia, from China, to the U.S. And that's against the trend that a lot of folks have been kind of frustrated with over the last several decades. So we're happy to share that technology with North America and with the rest of the world, the lessons that we've learned, the expertise that we've developed, and bring that here for the benefit of mankind, if you really think about it, right? Because the electrification effort is good for all of us. So we really want to play a foundational role in this movement, right? And we're willing to look beyond just straight, profit and loss, et cetera, for graphics, and really be a player, a good player, right? A good teammate in this transition with our customer counterparts and our supplying counterparts and the regulatory bodies, the states, the local governments, et cetera. This is a win-win for everybody to make this happen. And we're absolutely, not only willing, but trying to be proactive in making this happen. So it's more than just making graphite and selling it to automakers. It's really about being a part of this transition, which I've been after my whole career, my whole life, really. I think not to wax too philosophical, but there's a finite amount of resources on the planet, and I want to leave, something behind for my kids that's going to be sustainable. And this has been, this is an effort that's very, very much in that right direction.
Yeah. Yeah, I mean, it's very hard for humanity to figure out sustainability. It's not in our DNA per se, right? We evolved in a world that was empty, and now the world is full, and we need to change our ways and become much more enlightened, actually, about how we're doing business on Earth, because we are currently shooting ourselves in the foot and creating a very uncertain future for future generations. Humans will survive climate change, but it's a question whether or not we will survive it with the grace and well-being that we've come for the last couple of 100 years, right? Riding the boom in fossil fuels. That source of energy is very, very large and dense, right? And it's hard to replace fossil fuels with other technologies. And, but we clearly have to do that. We have the technology. We have to make the transition. It's a question of, can we do it fast enough? So, well, I will let you go, John. I really appreciate your time and what you guys are up to at Graphex Technologies. How can our listeners reach you, John?
Directly, I can give you my contact info. We have a phone number that's published on our website that will usually find its way to me. I'm on LinkedIn, and my email is on there, john.DeMaio@graphexgroup.com. So I'm readily available. I try to publish as much as I can, just status updates about Graphex, but I also have been asked for a number of bylines and whatnot about the industry itself. So I like to be considered an industry resource, not just a graphite guy, so to speak. So LinkedIn's probably a good place to go. Again, the website needs a little bit of a refresh, but people can reach me through that as well. But I would say LinkedIn's probably the most direct way. And of course, like I said, my email is available on that.
Great. Well, check out all of our content at cleanpowerhour.com. Please give us a rating and a review on Apple and Spotify so that others can find this content, and subscribe to our YouTube channel. We have all of our interviews on YouTube, as well as a weekly news roundup that I do with PV Magazine journalist John Weaver. With that, I want to thank John DeMaio for coming on the show today. Let's grow solar and storage. I'm Tim Montague. The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more.